Hey, this is Mr. Ariel with a video for balancing chemical equations. Before you get started, make sure you've got a paper copy of this sheet because you'll need to write a lot of things on it as we go along. This is really notes and a worksheet combined together. Now, if you reach way back in your memory, you've probably been taught about the law of conservation of matter. It states that matter is not created or destroyed during chemical reactions. It only changes form. Sometimes it's called the law of conservation of mass, but they're really the same thing. Now, moving on to this thing called balancing a chemical equation. You don't have to write this part down. I just want you to see an example of what we're going to do, and we'll come back to the notes to see what gets written into your paper. Now, let's go back to a chemical equation that I think you've seen somewhere along the way. This is sodium, and it's going to react with chlorine gas, happens to be two atoms attached to each other, and the product is going to be sodium chloride. That's NaCl. Now over on the left, we have one atom of sodium, and then on the right, we have one atom of sodium, so everything's fine with that. But if you look right here at chlorine, there are two atoms of chlorine on the left, and then there's only one atom right here. And so the way this equation is written right now, it's like you have to wonder, where's that missing chlorine? Because we had two on the left, and there's only one on the right. And by the law of conservation of matter, we know we can't destroy an atom, so it's not possible to have two atoms of chlorine and then end with only one. And so balancing chemical equations, that's going to give us a way to make it so that there are the same number of atoms of each type on both sides of the equation. So again, you don't have to write down this example, but go back to your note sheet and definitely write in this reason for balancing chemical equations. And that reason is we have to have the same number of each type of atom in the reactants and the products. This word reactant, I think you've learned it in a previous class, probably physical science, but that's the scientific word for the ingredients that go into a reaction. So pause the video, get this into your notes, and then let's move on. Now we'll get into the how you balance equations in a minute, but for now there are a couple of ideas that we need to review first. First up, let's look at the difference between subscripts and coefficients. Subscripts are numbers like the 2 that I'm writing into the formula for water. The 2 in H2O means that there are two atoms of hydrogen in a water molecule, and we also know there's one atom of oxygen, but you probably know that we never write that one. We leave it off. Now for the notes, subscripts only apply to the atom to the right of where they're written. Next up we have coefficients, and those apply to all atoms in the substance they are written next to. Let me add a coefficient to this water. I'm going to put a big 3 right out in front. You can think of coefficients. You can think of a coefficient as distributing, and if this was math, we could probably use parentheses to show that that 3 multiplies everything that's inside of the parentheses. Let's get a little bit of practice. In this molecule, C2H6, we're going to count the carbon atoms, and that would just be 2, and then the number of hydrogen atoms would be 6. But if we put a 2 out in front, remember that's kind of like putting parentheses around the molecule, and we're saying we have 2 sets of this molecule. And so now we'd have 4 atoms of carbon, and there would be 12 atoms of hydrogen. Moving over to C6H12O6, that's glucose. It's going to have 6 atoms of carbon, 12 hydrogens, and then 6 oxygens. But if we put a 2 out in front, I'm going to draw the parentheses probably one last time, that means we double everything inside. And so that's going to be 12 atoms of carbon, 24 hydrogens, and then 12 oxygens. If you've got that, let's go ahead and move on. Now there's just one more set of ideas we need to pick up on before we actually balance some chemical equations, and that's types of reactions. Reactions come in a few basic types, and we need to learn what they are and how to recognize them. First up is a synthesis reaction. Synthesis means to combine, and that's exactly what happens. For an example formula, I'll use what I had in the notes earlier. We have sodium plus chlorine produces sodium chloride. And again, this equation is not balanced. We don't have the same number of chlorines on both sides. We'll get to that in a minute. Now the general form for this reaction, you need to memorize that a synthesis reaction looks like A plus B makes a product of AB. In other words, the two elements come together to make one product. Now there's another way to remember it. If we had Princess Leia and Han Solo meeting up at a dance and then dancing together, that's kind of like a synthesis reaction. Now you don't have to draw these exact pictures into your notes. I just put them in because a lot of students struggle with some of these other kinds of reactions that are a little bit more complex. You could just draw stick figures for this part of the notes and you'd be able to get the concept down into your notes pretty quickly. Pause the video and get something on your sheet, but I'm going to move on to the next type of reaction. The next kind is called decomposition. and that means to break apart into simpler substances. For an example, let's use water. It can break down and form hydrogen gas and oxygen gas. And again, that equation is not balanced. For the general form of the reaction, we're going to say that this is AB as a substance, and it breaks apart to form A plus B. Going back to the Star Wars example, if we have Han and Princess Leia, and then they break up, that's kind of like a decomposition reaction. All right, next up we have single replacement. For an example, we could use copper plus hydrochloric acid, that's HCl, and that makes copper chloride and hydrogen gas. For the general form of the reaction, we're going to say that's substance A, and then another substance, BC, and then it produces A, but now it's matched up with C, and then element B is off by itself. So the reason this is called single replacement is because a single switch took place, like copper and hydrogen swap places. Going back to the Star Wars example, if Han and Leia are dancing together, but then a new Jedi shows up, and Han gets kicked out, and Leia dances with that new Jedi, it's kind of the same thing as a single replacement reaction. Now for the last reaction, we've got double replacement. For that, let's use this equation. For the general form of this reaction, we're going to say this is A, and then this sulfate right here, that's B. And then we've got calcium is C, and chlorine is D. And then over on the other side, we've got calcium, that's C, but it's matched up with sulfate, and so that was B in my example. And then we've got lithium, that's A, and it's matched up with chlorine, that was D. Going back to the Star Wars example, a double replacement reaction is like having two sets of people dancing, and then they both swap partners. Now the last type of reaction is called a combustion reaction. That's any reaction where a hydrocarbon reacts with oxygen to form carbon dioxide and water. Hydrocarbon might be a new word for you, but it's any substance that only contains carbon and hydrogen, and it can come in a lot of different ratios, so we have an X and a Y built into our formula here. Now this one doesn't fit into the Star Wars examples, so a different way to remember it is that combustion is pretty much the same thing as burning, and you probably know that requires oxygen and it produces CO2. Make sure you've got all this in your notes, and then let's move on into actually balancing some equations. So there's some rules for balancing equations, and I already wrote them on your paper. The first step is to count the number of atoms of each element on each side of the arrow. We draw a little table, just like this. You put the vertical line right under the arrow, and then we're going to count up the atoms on both sides. So that's sodium and chlorine, and then I'm going to put them in the same order over here on this side. Now over on the reactants, we have 1 atom of sodium, and we have 2 chlorines, and over on the products, we have 1 of each. Now step 2 says add coefficients to make the atom numbers balance out. Adjust your counts. So remember that coefficients are numbers that are written out in front of the substance, and the atoms I need to balance right now are chlorine because we have 2 on the left, but only 1 on the right. So I'm simply going to add a 2 out in front of sodium chloride, and then adjust your counts. That means that we have to change everything over here because now we have 2 sodiums and 2 chlorines. Now we repeat that step until all atoms are equal in number. So I have sodium with 2 on the right, but only 1 on the left. So I can double sodium by putting a 2 coefficient and then update my counts, and everything is perfectly balanced. Now the last step is to reduce coefficients to the lowest whole number ratio, and I'm going to write this 1 in front of chlorine right now. And if you notice, a 2 to 1 to 2 ratio is already the lowest that it can possibly be. I'll take that 1 out because we would never really write that. Now for the type of reaction, let's get a little practice with that. I have a substance A, and then B, and then together they make AB. So this is going to be a synthesis reaction. If you've got that into your notes, let's move on to the back of the sheet. All right, so on this one, we're going to draw that table. We're going to count up the atoms on both sides. So there'd be 2 hydrogens, and then there are 2 oxygens. And on the right, we have 2 hydrogens and a single oxygen. So now I need to add coefficients to balance everything out, and oxygen is the issue right now. We need more on the right. So I'm going to try a 2 right here. That'll update everything, and I have 4 hydrogens and 2 oxygens. So now I just need to balance hydrogens, and I need 4 on the left, and so I'm going to put a 2 out in front, and that's going to be a 4, and now everything is perfectly balanced. For the type of reaction, that's A and then B, and they came together to make a new substance AB, so that's synthesis. Moving on, I want you to try this one by yourself. Pause the video and then come back and check your work. All right, check your answer here. If there's something you missed and you're confused about it, be sure to ask me in class. I'm happy to help. Moving on to the next problem. Let's try balancing this one. It's a little bit more complex looking. So I've got iron, I've got sodium, and I've got bromine. And I've got one of each over on the reactants. And now the next issue is that we want to keep things in line. So even though sodium shows up as the third element on the products, we're still going to list them in the same order that we had in the reactants. It just helps to keep things in that order. Now we've got one iron, we've got 3 bromines, and 1 sodium. So I just need to look at the bromines because I have 3 on the right and 1 on the left. So I need a coefficient there, and that'll make 3 bromines, but also 3 sodiums. So I can fix that pretty quickly by putting a 3 out in front of sodium, and then everything's balanced. Now for the type of reaction, we have A, and then this is a different substance, BC, and we end up with A attached to C, and then B is off by itself. So this is a single replacement. And if you've got that, let's move on. And here's a pretty complex looking equation, but we'll get it balanced. It's not going to be too bad. Let me start with my element list. So there's sodium, and then this is a new thing. We're going to list out the sulfate. It's a polyatomic ion, but it shows up on both sides of the equation in the exact same form. And so we're just going to count it as a set of sulfate. I mean, there's only one sulfate ion on the reactants. So I've got calcium and I've got chlorine, and those are 2 sodiums, 1 calcium, and 2 chlorines. So when we put them in the same exact order over here on the products, and now I've got 1 sodium, 1 sulfate ion, 1 calcium, and 1 chlorine. So the only thing that's out of balance is the sodium and the chlorine, and I'm going to need a 2 right there, and that'll fix this and that. So everything's balanced now. For the type of reaction, this is A, and remember that sulfate, that counts as B, and then we have C and D. And then on the other side, C is now matched up with B, and then A is matched up with D. So this is a double replacement. All right, if you got that one, let's move on. I want you to try this one all by yourself, so pause the video and then come back and check your work. All right, check your work. If there's anything you're confused about, be sure to ask in class. Moving on to the last problem. This one I want to work out together, just to show you one that's a little bit more complex. But I'm going to speed up the first part of counting those elements. All right, I've got that done. It's important to notice that oxygen shows up in both products. There's 2 oxygens in carbon dioxide and then 1 in water. And so we only listed in the table once, and that's going to be 3 atoms. Now this one's going to be a little bit more complex to balance, but we'll get it. Carbon looks like it has 2 on the reactants, but only 1 on the products. So I'm going to try fixing it by putting a 2 out in front of carbon dioxide. And that changes carbon. It's going to be 2 now, but it also affects the number of oxygen. But it doesn't make oxygen 6. We just doubled these 2. So now there's 4 oxygens. And then we have to add on the 1 oxygen over here. So that makes a total of 5. Now the next thing I'd try balancing is hydrogens. We have 4 on the reactants and 2 on the products. So I can fix that by putting a 2 out in front of hydrogen, and that'll make 4, but it also changes the number of oxygens. So instead of having 1 right here, now we have 2. So that updates our total to make it 6 oxygens on the products. So now I'm going to need 6 oxygens over on the reactants, and I can do that pretty easily by putting a 3 right there, and we have 6 oxygens, and everything's balanced. And the last thing we need is that type of reaction, and while it might look kind of like a single replacement reaction, remember that anything that contains carbon and hydrogen only is a hydrocarbon, and we're reacting it with oxygen and essentially burning it, and so this is combustion. Now that's it for the notes and the practice problems. I hope this video has been helpful to you today, and as always, thanks for watching.